Hey, it's Dempsey here from Python video, where we help you in using Python for water resource and related fields. Hello everyone. Today in this video I just want to talk about pre-processing of Ethiopian National Meteorological Agency data in Python. The objective of this video is to read and prepare the data with a single column format. So usually we collect the data from Ethiopian National Meteorological Agency with this fixed Excel format. As you can see, the format has at the first column there is an ID, at the second column there is a name of the station, at the third, at the fourth and at the fifth station there is a latitude, longitude and elevation of the station, and this column have an element part, and this column is very important because every variable collected by this office will be inserted in here. For example, as you see for Adaitu station there is a temperature maximum and a temperature minimum, but if you are taking another station there will be precipitation, relative humidity, wind speed and other variables. So this column handle this all variables. The next column have a year values, and the next have the months, and the horizontal this line has a days. So this is the fixed Excel format that's collected from this office. Unfortunately, we hydrologists suffer challenges with the models that's not interested in this format. All the models that we are working on is demanding a single column format. So this is the format they demand. So if we need to put at the row 1 we need to put day 1 means 1, at row 2 we need to put means 1 day 2, and we need to go further ahead with a single column format until the end of the year. That's the work we need to work on. So what is the problem? The problem is this work is very repetitive. It takes days, weeks and months. I know it depends on the use of Excel tools like recording. We can deduct our time. Yeah, I know. If you are using the lesser number of years, lesser number of stations also, it will deduct your time. But I know that until it takes your days. But in this video I can show you that how you can manage this thing in a minute run of Python. So let's go ahead with the code. Before starting the code, let me put some kind of note. So this video assumes that the user already has a Python installed with some kind of editor. Maybe the editor can be Jupyter Notebook, Spider or PyTorch, I don't know. There is some kind of editor in your computer. If not, please pause the video over here and install it. If you encounter any problem, let me know. I will make a video about it, or we can solve it through another communication also, email and others. Okay, let's go ahead. So the first step that we need to work on is we need to import packages. So the packages that is useful for this code is Panda package, X-ray, NumPy and collections. Just import this package. First, I know at this point you need to install this package in your environment first. So install it in your environment and come to here and import it. The second and the most important part we need to work is we need to define a functions that will help us doing this work. The first function that over here is it will trim all the columns function. So this function will work. It will remove any white space in the data frame before and after the values. So if there is any white space, maybe in the data frame, because this is large data, so there will be at one point, so it will clear out every single white space in the data frame of values. The next column, the next function is drop column function. So this function will work on dropping the columns. So we are working on so many columns in the data frame, so it will drop any column that we don't want to work on. The third function is rename columns function. So at this stage, this function is very important because usually the when the office collects the data, maybe there will be a spelling mistakes. For example, maybe the elements can be recorded as capital E in some kind of files, and it can be a small e in another file. So this function will create some kind of Gerard method of matching index. So based on that index, it will create some kind of columns, which is fixed columns, and it will rename every single column over there with a uniform column names. So we use this function for that purpose. So the function number 4 and number 5 is very clear, I think. If not, we will go over it. So this is the first step. We need to import every important packets and functions. The next is let's read station data from National Metrological Agency. So to read this data, we need to import the path first. This is our path, my path. I think you will have another in your computer. So import the path, and after importing the path, you can say that Panda, this is a Panda, read CSV because my file is CSV. So path, and just add an addition button plus. So this is my file name, Amashto. So just call it like this, and welcome. So we just call our data, but the other thing we need to define at this point is the column name that we want to drop, the column names that we want to rename it, the column names that we want to replace it, and the variables that we want to keep. So at this point, we just want to remove these columns, we just want to rename these columns, and we just insert these columns with these new names. And at this point, we just want to keep the variables like temperature maximum and temperature minimum in station data. So if you are taking some kind of another station over here, maybe you will have another element like precipitation, relative humidity, and others. So you can keep your variables over here, but for this tutorial we just already have 2 variables. So let's run first this one, and let's run this one. Okay, so we just imported our data. The next is let's clear out our data. So if there is any white space around there, I will call the function on the above as I showed you right here. So I just call the function and I run it. So it will clear out if there is any columns. The next one is we need to rename the columns. So as you can see from here, we need to rename latitude with lat, longitude to long, element to elements, year to years. So it will replace all of them, like as you can see, lat, long, year, or are changed. So we rename it. So at step 2, we import our data from the path we already had, and we define the variables. We clear out our data and we clean out our National Metrological Station data. The next step 3 is we need to start rearranging this data frame that we can work with an X-ray. The first thing, we need to call melt function. This is a Panda function. So melt will work. It will classify the identified variables and measured variables. So at this point we said that years, lat, long, months, and elements can be our identified variables, and the other will be our measured variable. So we just put it like that. So this is our identify variables, yes, lat, long, length, and the other will be measured variables. The next thing we need to do on is we need to replace these variables with day. So at this point the code says that please replace variable with day, and it already did. And at the next point we need to combine year, month, and day values. So we just replace variable with day, and we combine year, month, and day with datetime panda function. So we just did it, and you can see over here year, day, and month is renamed like this. The variable column over here is renamed by day. So let's go ahead. The next thing to do is let's create time column, and as I told you, we combine year, month, and day. We just combined it, so we can delete day, month, and year from this data frame. So let me run this one. So let me run this one. So as you can see, we just delete year, month, and day, and the last variable can be like this. It's time, it's values of the element is longitude and latitude. So the next thing we do is we need to create some kind of temperature maximum and temperature minimum column alone, a new column, and we need to put every single values over there. So these codes will do that, and the other thing this code will do is if there is any empty space, it will replace it with none, and we change it the value to float type, because this float helps us in math in plotting. So we change it the values like that. So I can show you the result how it seems. So this is the last result. So this is our time, and this is our latitude, longitude, and this is the variables that we want before. So this is our last output, but we need to save this output. So as step 4, we need to run the saving code for it. So let's run it. So it's already saved. So our data name is newest to XR. So newest to XR is saving in my path without a to CSV file. So this is my path. So this is out a to. So this is our last result. We do have time column, latitude, longitude, temperature maximum, and temperature minimum. So it worked very well. The code worked very well. But we can check it out. For example, let's check it out. 1994, month 3. Yeah, we can work. Month 3, day 1. Okay, it says it is 34.4. 1994 03 01, day 1. So let's go to this original date, original data. So day 2, 1994, month 3, day 1 is 34.4, and the code really work, and it's really validated. So you can use this code if you have any single station with many variables. You can use this code. Thank you for having me at this point, and the next video will be pre-processing of this data by considering many stations, because we hydrologists suffered with a basin level, a national level stations. So how we can run including those many stations in one code. So I can come up with the video like that, and at the next I will come up with how we can twin the station data into gridded data for comparison and any modeling purpose. Thank you very much. Have a product